This video clip will show you how to calculate the height the rock was thrown up by how long it takes. So if you throw a rock up in the air and it's in the air for 2.8 seconds, how high did the rock go? There's an equation for an object in free fall, negative 16 t squared, where t is the time that it's in the air, plus h equals 0, describes a situation where h is the height in feet from which the object is dropped, and t is the time in seconds it takes for the object to reach the ground. So this is just if you're dropping something. Well, when a rock is thrown up, the rock's upward progress is slowed down by gravity at the same rate that it is accelerated down once it reaches its highest point. So the time going up is the same as the time falling. So the time it falls is half of the total time in the air. So for a hang time of 2.8 seconds, the fall time is 1.4 seconds. So half of that time it's going up, half of that time it's going down, and we can solve for the height. Now we can verify that with a high-speed video camera, and we will do that. Not in this lesson. In this lesson, we're just going to say, okay, well, if that rock fell for half of the 2.8 seconds, then this equation is equal to 0, and we can find the height. So we'll just say 1.4 times 1.4, or square it, times 16. So that equals negative 31.36 plus h equals 0. Let's add 31.36 to each side. So the height equals 31.36. And that is in units of feet. This particular, the 16 tells us that we're talking about feet. So if a rock is thrown up and stays in the air for 3 seconds, how high did the rock go? Well, we want to take half of that time and say that it was in the air for 1.5, it fell for 1.5 seconds. And then we can use that equation. We can say negative 16 times 1.5 squared plus h equals 0. 1.5 squared is 2.25 times 16, negative 36, plus h equals 0, so h equals 36. If the rock is thrown up and stays in the air for 2.6 seconds, how high did the rock go? Half of that time would be 1.3 seconds falling. So 1.3 squared is 1.69. I'm going to multiply that by 16. 27.04. Probably for how accurate we can measure, 27 feet is close enough. We're going to be measuring these times with stopwatches, so we won't have a whole bunch of accuracy. 3.2 seconds. 0.6 seconds for falling. 1.6 squared. 1.6 times 1.6 is 2.56 times 16 equals 40.96. Let's call it 41 feet.